The F-35 Joint Strike Fighter program, led by the United States and involving numerous allied partners, has entered a new phase of development with renewed interest in extending the aircraft's unrefueled range through the use of external fuel tanks. This initiative re-emerged in the U.S. Air Force's fiscal year 2026 budget request as part of the Block 4 modernization program. The stated goal is to evaluate feasibility and decompose requirements for integration of external fuel tanks to support long-range missions of the F-35. This is not the first time external fuel tanks have been considered for the F-35. Early in the aircraft's development, between 2004 and 2007, Lockheed Martin designed and tested concepts for underwing drop tanks. The two main designs had capacities of approximately 480 and 460 gallons. However, both were ultimately shelved due to aerodynamic issues, particularly concerns with store separation, safe release of the tanks during flight, as well as negative effects on performance and stability. These tanks also presented challenges to the jet's low observable stealth characteristics due to their shape and placement under the wings. A new push for range extension resurfaced around 2018 to 2019, coinciding with growing operational demands in large-scale theaters and increased adversary anti-aircraft capabilities. The challenges of operating at extended distances from secure airfields or tanker aircraft made longer unrefueled range a high priority for survivability and mission effectiveness. The combat radius of the F-35A, the U.S. Air Force's conventional takeoff and landing variant, is around 670 nautical miles, 1,241 kilometers, without aerial refueling, when flying with internal fuel and weapons in its stealth configuration. The F-35C variant, optimized for carrier operations, has slightly more range due to larger wings and greater fuel volume. The F-35B, which is capable of short takeoff and vertical landing, has the shortest range because of space taken up by the lift fan system. All F-35 variants can refuel in flight, but aerial refueling operations are resource-intensive and potentially risky in denied or contested environments. External fuel tanks offer a relatively straightforward method for increasing range and loiter time. However, they introduce compromises. Traditional drop tanks increase drag, reduce maneuverability, and significantly degrade stealth by increasing radar cross-section. This reduces the aircraft's ability to penetrate defended airspace undetected. In certain mission types, especially during the early stages of a conflict where stealth is critical, this would not be acceptable. However, for lower threat environments or post-penetration operations, external tanks may be viable and desirable. One potential solution that could preserve more of the F-35's stealth is the use of conformal fuel tanks CFTs. These are fixed tanks that conform closely to the aircraft's surface, reducing drag and radar signature compared to drop tanks. CFTs have been used on aircraft like the F-15E and F-16 Block 60. While less flexible, they are not jettisonable. CFTs allow for persistent range enhancement without dramatically altering the aircraft's flight profile. Design work on CFTs for the F-35 has been explored in the past, but no current U.S. program of record exists specifically to implement them. Whether the new external tank efforts will focus on drop tanks, CFTs, or a combination of both remains unspecified in the FY 2026 budget documentation. What is clear is that this work is included in the $432 million request for ongoing Block 4 upgrades under the Continuous Capability Development and Delivery C2D2 framework. Block 4 is a multi-year modernization package that spans all F-35 variants and includes major upgrades to sensors such as radar and distributed aperture system, electronic warfare systems, communication systems, navigation capabilities, and weapons integration. The Block 4 effort is essential for ensuring that the F-35 remains effective against modern integrated air defense systems and next-generation threats. Another technical challenge with external fuel tanks, especially for stealth platforms, is ensuring they can be cleanly separated from the aircraft when empty or damaged. Stores separation is complex due to aerodynamic flow, speed, and pressure. Improper release can result in collisions with the aircraft or unstable flight conditions. Lockheed Martin's earlier drop tank designs had to be heavily modified due to these issues. Any renewed design would likely need extensive wind tunnel testing and flight evaluation before integration. Additionally, the logistics and support infrastructure for external tanks would need to be re-established. This includes training, maintenance, flight certification, and software updates for fuel management. External tanks would also impact aircraft performance, weight, and balance, particularly during catapult launches or vertical takeoff operations in the case of the F-35B and F-35C. While no fielding timeline has been provided, the inclusion of this work in the FY 2026 budget suggests the concept is in the exploratory or early development phase. If results are favorable and integrated into the Block 4 roadmap, initial operational capability for external fuel tanks could occur later this decade or early in the 2030s, depending on testing results and procurement cycles. Separately, it's worth noting that future aerial combat strategies are increasingly emphasizing range, endurance, and survivability. The U.S. Air Force is planning for its future sixth-generation fighter, known unofficially as the F-47, to have a combat radius exceeding 1,000 nautical miles, reflecting the growing need for long-range tactical aircraft. In this context, adding fuel capacity to the F-35 would help maintain its relevance alongside newer platforms. Longer range also reduces the number of tankers required for missions, eases demands on logistics, and increases the operational flexibility of the F-35 fleet. Stealth-compatible drop tanks are already in development for the F-22 Raptor, indicating technical pathways that could benefit the F-35 if successfully adapted. These tanks use shaping in materials to reduce radar signature and may provide a compromise between fuel capacity and survivability. However, even with stealthy tanks, they would still need to be jettisoned before deep penetration missions in heavily defended airspace. The F-35 external fuel tank initiative reflects a shift in operational priorities toward endurance and independence from vulnerable support assets like tankers. While still in its early stages, the effort is technically feasible with modern materials and aerodynamic design tools. Its success will depend on achieving a balance between range increase and the preservation of the F-35's unique low observable capabilities.